right? So here's this table you can look up in the books. Basically just telling us if we take a composition of a function and its inverse, they should cancel as long as the domains are acceptable, right? The example is this, right? If I take the tangent of the arctangent of -5, I have to ask myself, is -5 in the domain of arctan? Yeah, it's all real numbers, the domain of the arctan. So yeah, that's fine. So that would tell us that the tangent and the arctangent cancel, and the answer is -5. -5 is in the domain of the arctan. So the function, the composition of a function and its inverse, they cancel. F of s minus 1 cancel. Okay, now the next one, they've reversed it, right? We've got the inverse, the composition of the inverse, and the inner function is the sine, actually. Is sine in the domain, is the 5 pi over 3 in the domain of sine, such that we can take this composition and have them cancel? No, because what does it have to be? -pi over 2 to pi over 2. This value is not in the range from -pi over 2 to pi over 2, which means you can't do the sine inverse of the sine and have them cancel out. It doesn't mean you can't solve the problem. I mean, we know that sine has the domain of all real numbers. It just in terms of using that property of f of s minus 1 cancel each other, we would have needed that to be between -pi over 2 and pi over 2. We can still find the sine of 5 pi over 3, right? That's a unit circle value. What is the sine of 5 pi over 3? -√3 over 2. So I can still do this. I can say this is the arc sine of -√3 over 2. And then that's a question I can answer. Where in between -pi over 2 and pi over 2 does the sine equal -√3 over 2? And of course, it's the same place. It just, we have to name it with an angle that's in between -pi over 2 and pi over 2, which is, no, that's not, -pi over 3, right? In terms of the, using the proper quadrants for this, we would have to say it's -pi over 3. What's that? Quiet, please. I can't hear. Right. I was determining whether, can I just cancel these two out and say the answer is 5 pi over 3? No, I can't do that because that's not between -pi over 2 and pi over 2. Now, what I can do, because I do know how to find the sine of 5 pi over 3, I can do it, right? And then find the inverse of that. What you find is it's not equal to what we started with. So that property didn't work, but we were still able to solve it. Yes? If it says exact, then don't, right? What about this one here? Cos of cos minus 1, right? Remember, what's the domain for the cos inverse? -1 to 1. What's the value of pi? 3.14. It's not in the domain, right? You're looking at it in a way like it's an angle. So in a way you think, well, of course I can do that, right? But that's actually not, we usually don't put angle measures inside the inverse function. So you need to just take it as a decimal. That is the cosine of the cosine inverse of 3.14. And then you have to say no solution because it's not in the domain of the cosine inverse. No solution.